Oh shit. I fucked up. I started streaming instead of recording. Good job, Andy. Gotta do that again. Hello and welcome to another Solana tutorial. Today, I don't really know exactly what we're gonna do today. But we're gonna definitely talk about transaction simulations. We're gonna talk about return data. And basically, I wanna build a program that behaves like an API would. And why do we do this? Well, this might be relevant when it comes to interfaces. And interfaces are probably gonna be something that every Solana dev should know about. So I wanna prepare. So we're just gonna play around with an anchor program today. And we're going to start with something that we should already know, which is just reading data from the network. So let's create ourselves an anchor program. API imposter. We're going to take that. Last time I said no, nobody is going to understand this, but I like it. Yeah, and since we're using Anchor, since we're using my computer, this is going to take a while. But that's probably too long. Oh, no. Hey. Easy. And we're gonna need the program. What do we call the program? API. API me. And I think I'm gonna work on DevNet. Fingers crossed that I can get an airdrop. Fuck! That's no problem. I have a VPN. I wanna get myself another IP. There we go. Literally limit to one freaking. Took a while, but managed. Oh fuck, but it's an anchor program and I need more than 2 sol. Maybe I should develop locally. That's literally, if I have a problem, Twitter, help me. I don't have dependencies. Let's see if somebody's gonna send me something. the things you gotta do. It's okay, to the interesting part. We are gonna work on DevNet. This program address. Lol, somebody sent me 4 sol. Thank you, Effe. Okay. So, I've got a simple Solana program, anchor program. Let's imagine we had, accounts. An account. Those are just examples. That's why it's hard for me to come up with shit. But let's say I have a data account and that stores some data, which, is a U. Then there is, remaining uses or remaining whatever. And that's maybe a U32. And then, we still give it, a name, whatever, which will be a string. And there might be more data in here. We'll see what we use. We keep the initialize, give it a lifetime. You just initialize this data account. Let's make it a PDA. Data account 8 plus 4 plus whatever the string length is, plus another 8 for the anchor stuff, so it really doesn't matter. This is just a demo. Let's say the name can't be longer than, okay, let's not just say that, let's save that. 20 characters for the name. Missing type. Okay, you can't infer that. Okay, make it a usize. Okay, so the max name length is 20, and so the max count size 8 for the count discriminator. 64 divided by 8 is another 8 and 4 and my name length. And this size we put in here to show how I can make proper program. Because in my videos I tend to, whatever, it's not important because this program is not used, but then I set a bad example. So might as well do it clean. There you go. And my seeds I've chosen, some signer, and I'm also gonna put the name in there such that one user can have several data accounts. So I'll also put the name into the PD because I can. That's why I can. But then the name I need to get from instruction data, and we have learned how to do this just with instruction. Then the actual instruction, of course, also needs to have the name. That should be okay. Then all the initialize does is just set the data. Actually, speaking of, let's also provide some data. Then I have data remaining and name. So the name should be the name. The data should be the data. And the remaining should be, I don't know, 69, because everybody's favorite number. And one thing, since we're building clean code, that we should definitely also do here, to set a good example, is to require that name length is actually under max name length. Otherwise, I'm gonna create an error. I don't know, name too long. There we go. I don't know why this stays red, but my Rust analyzer doesn't like me today. Let's see if it builds though. Anchor build. Uh-oh. And it's good that we see this, because those are just the things that you need to know. Because the first time I saw it, it took me a few hours to fix it. And once again, I fixed it by asking people on Twitter and they helped me. So apparently this get random numbers stuff is not supported. This essentially, it's because version numbers, Anchor isn't compatible with the newest Solana version. So I need to downgrade that. What do I need to downgrade it to? Use these dependencies to solve for now. We will just use these dependencies in our cargo toml. Now, you gotta pick the right cargo toml, because there's this cargo toml here on the project level, but you wanna pick the one from the program. So inside the Rust stuff. Here is another cargo toml that contains dependencies, and here we're gonna add those. And when we did that, build it again, and hopefully this time it works. That's just a quick fix how to get your Anchor to compile again. And if you don't know about it, then it's not such a quick fix. So you're welcome. Why does it need to install SBL token 2022 in this and in this version? Seems like the dependencies are a bit weird. And here we got it. This is not compiling at all. Oh, I forgot the system program. Yes, of course I did. If we init, we need the system program. Thanks for reminding me. Program with info and system. Can do what else? Oh, it's error code. It's error code. What else? That's it. Cool. Perfect. It compiles. Which means we can... No, actually, first I would like to set seeds to true. Build it again, because then I can do seed inference. And then we're gonna just deploy it. Oh, we're deploying to local? No, I told you should deploy to definite. Oh. Now I told you. Actually, keep here. Now you can deploy it to this address. There we go. So quick recently. Definite has become a lot quicker. I love it. So I've got the program deployed. Let's test it. I'm just gonna create a quick little node script. I don't know, I call it run because I'm not creative. One day I'm gonna learn it by heart how to do this, such that I don't always have to call my function or find my function. Key pair from secret key. Okay, then we have a key pair from which we can build an Anchor wallet. Provider needs the connection and the wallet. Then with the provider, and we can create ourselves the Anchor program. If you do this a bunch of times, then this just runs automatically, you know. And I want this to be a AP imposter. And the program gets the IDL. I'm gonna just hardcode the program ID because why not? The provider, we also just created that. Perfect. So IDL and API imposter we get from this nice types here that Anchor creates when it builds. So we've got this and the IDL. So I just need to import that. Import from target types this file, both the type and the IDL. Easy. Then we have the program with the right type. So we can now, probably in a function, run. Do stuff like program dot methods dot initialize, and then I give you the accounts. Nope, wrong. I give you the data. The data was name and data. So I don't know, a new big number. Ha! There we go. Okay, that always takes a while to get the types correct. But here we have it. So we have a first name that is under 20 characters. I just put in other data, and then I provide the accounts for this. Here we need the object, the data, system program, and user. System program, it should be able to infer automatically. Data, it should actually also infer automatically because that's a PDA. So let's just provide the user, and this is just gonna be my key pair because why not? And interestingly, it does not give me an error here that it requires the other accounts as well. Nice, because it will be able to infer them. I don't need to sign because Anchor, if I use it like that with this provider, automatically signs with this wallet. So I can just literally RPC this directly. And we're gonna await this, log our signature, and then we see. Let's run this. What? TS node not found? Lol, I'm gonna start it from Windows because I can't be bothered. TS node run. Seems to work. There we go. Transaction goes through. We've created this account. Probably written a bunch of data into it. Perfect.
So we could call our program. Cool. And now
to the things that we actually want to play with today. So let's talk a little bit about transaction simulations. If I run this again, then it will fail. Demonstrate. Now, question to you, why does it fail? Do you know? I don't want to spoil it yet. Give it a few moments to think about it because that's something that by now you should know if you follow my videos. What error are we getting? 0x1? Is it that one? No, it's 0x0. 0x1 is in fact insufficient funds. I also make mistakes sometimes. But yes, we got the 0x0. And why is that? Well, because the account already exists. Because we derived the account with the exact same seeds. Because we have the exact same name and the exact same user. And remember, those were the two things that we derived the PDA from. If they stay the same, it's gonna be the same address, and therefore, if I try to init it again, it's not gonna work. So we get this error here, and it tells us transaction simulation failed. Why is that? Well, because the RPC server, before it submits the transaction to the cluster, will actually perform a simulation of the transaction. And if that simulation fails, then it doesn't even submit it to the cluster because we don't want to spam the Solana validators if the transaction is not going to go through anyway. We could get around this. We could force the RPC to send the transaction by not letting it simulate, and we do that with a skip pre-flight. Maybe you've seen that option before. Where can I put options? In here? Yes. I can here skip pre-flight, set it to true. If I do that, then it will not simulate the transaction, just pump it out, and then the transaction is going to fail. So essentially it's going to cost me a transaction fee without actually a succeeding transaction. Maybe that's an Anchor thing, that it doesn't properly show that. Let's check if I see a transaction here. Yes, here I do. So apparently Anchor doesn't neatly return the signature of the failing transaction, but fails to catch something somewhere. It doesn't matter. The result is still that we get a transaction which has a different signature, even though it has the same message. Why does it have a different signature? Question to my students. Why? What changed? If the message was the same, all the things we're doing in here is the same. We have the same accounts, we have the same data. Why is it still a different signature? We have the same signer, right? The user here, this guy also signs with this key pair. Why is the signature different? What did you say? Because of the block hash? That is correct, because of the block hash. Because of course, this one will have a different recent block hash, therefore, the message part is different, and therefore the signature is also different. But anyway, we see that here we now actually had to pay the transaction fee, 0.000005 sol, and the transaction did not go through though, because same error, 0x0. So we could have saved ourselves this transaction fee by letting the RPC simulate our transaction. So it does make sense in most cases to keep pre-flight on, like to not skip pre-flight, double negatives. So to set it to false or leave it to false, because then we get the transaction simulation from the RPC whenever we send a transaction. Now, we can also simulate a transaction without actually sending it. Hold on. One step before that though, instead of sending it here, I can get the transaction from here. I could also get the instruction and then put that into a transaction, but I'll just get the transaction here. And then I'll manually send it. And yes, this is deprecated because it's not a version transaction, but I don't really care. Here I need to put in the signer though. And I can set skip pre-flight to true again, because this I think gives me a nicer error. Yep, in fact, it does not give me the error, it gives me the signature. That's what I expected from here as well, but here I get the signature, and we're gonna see the same thing as before. Yet another signature because yet another block hash, but the program failed, so we get error, and we pay another transaction fee. Our program failed because the system program allocate through the 0x0 custom program error. If you watch the video on errors, yep, we did a deep dive there as well. Already in use. Yeah, so the address is already in use, and we don't see it because we were skipping the pre-flight checks. If we don't skip them, then the transaction simulation would give us the result, hey, 0x0 from the system program, this transaction will fail. I won't send it. That's also what we saw before. And we get the logs. And here we already notice one thing. Those logs show us what the program would have said if the Solana program would have actually been called. But the Solana program wasn't really called. It was just simulated. Like on the Solana cluster, nothing happened, right? We didn't submit a transaction or anything. But the RPC executed the program essentially with the state that it has, and then it gives us the result. So it's as if we execute the program without actually executing it, really. Like, okay, in a way we execute, in a way the RPC executes it, yes. But it's not like on-chain executed by the validator and checked by the validators. And we're gonna take this to our advantage soon. I still want to keep talking a little bit about simulations though. Not only does every send transaction per default simulate the transaction, really the RPC does it. But we can do that manually. We can say, I want a simulation. Also from the connection, it has a simulate transaction, which is again deprecated because it should use a version transaction, but we're gonna ignore that for now. And what it takes is the transaction or the message. So it's just the message part of the transaction, you know, that the part without the signatures, the part that is taken into account for signing, because the transaction also contains the other signatures, but the other signatures are not taken into account when signing, obviously, because they need to be independent, right? You can have several signatures and each of them just sign the message and not the entire transaction, which also includes the signatures, right? Does it make sense? If not, doesn't matter. Not so important. So essentially, we can keep it high level and say, we put in that transaction here, but we could also just put the message and the signers. So I'll put my transaction here. Then I get oh wait, I need to await this. Then I get an RPC response in context with a simulated transaction response. This simulation now has a context and a value. The context basically is just, you know, the slot. Interesting is the value, because here we have the logs, the error in case an error occurred. I also get some accounts and some return data. Now we're gonna have a look at that soon. You know, let's just log the entire thing. Why not? Let's see if it logs that nicely. And I just put in that transaction. I did not even sign it yet. So in this case, we might even get a signature fail. Wow. Transaction fee payer required. Yes. Aha, so it doesn't anchor here. If I get the transaction, it doesn't even set the fee payer or the block hash apparently. Is it enough if I provide the key pair here? I don't think so. Maybe it now tells me I don't have a block hash. Nope, that looks better. That looks like what I would expect now. So the context is we have this version, so it's running 1.14.18, our RPC, I suppose. And it was working on this slot. So that's when it simulated that, because, you know, context is important. A transaction might succeed on one slot, but fail on a different slot because the data is different, because the state has changed between those slots or might have changed between those slots. That's why this is important for context. That's why it's called context. But then we have the value, which tells us, well, what are the logs and what is the errors? We don't have return data. We did talk a lot about errors in that one error video. So we get an instruction error, which is, and this whole thing here is a transaction error, and the error of the transaction error is the instruction error. In instruction 0, we have the error that it now doesn't print nicely anymore here, but we know that it is from the system program a custom error 0x0, which basically means that the account is already in use. Yes. Okay, so that is our simulation. We get the logs and the error already in the simulation. And now we could do something like, okay, if our simulation does not have an error, then we send it and skip pre-flight. We could do something like that, you know? So we now split it. First, we ask the RPC, hey, can you simulate that for me? And then if the simulation goes well, then I actually send it. Even though we now, since we're signing twice, we have a different block hash here than we have here. So even though the simulation might actually go through here, it might already not anymore. Whereas if we just simulate it with pre-flight, then it would be the exact same transaction because we already signed it once. But we're getting into the details here. That is not really important, and that's also not what I want to do here today. I'm just, talking in general about simulation, because transaction simulations is an important topic. I want you to understand the difference of the transaction simulation has failed to the transaction has failed. So the transaction returned an error. There is a massive difference, not only because for one you actually pay the transaction fee and for the other one you don't. Anyway, we can simulate with this deprecated. I kind of want a version transaction. Can I make it the version transaction such that I don't get the deprecated one? Versioned transaction. So here I just get the instruction now. I'm gonna put the one instruction here. And now I need to provide the recent block hash and the fee payer. I'm just gonna code it in here. So I need to now provide the fee payer and the recent block hash and my instructions, and then I have the message, and then the message is fixed. So now when I use this in a version transaction, and I'm gonna simulate the version transaction, then this is gonna be different because the version transaction now needs version transaction simulation configs. I have no idea what that is. Accounts commitment, just gonna leave it empty. This one I could now, of course, no, first let's simulate it and see what comes back here. I like how I just have a hair standing up there because I'm a rebel, that's why. There we go. And that was simulated. And it was simulated without us signing it, right? So that's another important thing. You can simulate a transaction without actually owning the key pair or the key pairs that are the signers. In my case, there's just one. So I never needed to provide my private key to simulate this transaction. I always just provided here the pub key of the key pair, and that's all that's required to simulate the transaction. Because obviously, we don't actually change the state because it's not actually submitted to the cluster. We just simulate it. And we can simulate without having the key pair. I provided it earlier such that it automatically sets the fee payer, but yeah. So now we could do something like, if there's no error, then we send the version transaction. Now, I like to do questions for you today. Will that work even if there was no error? Will it work to send that transaction? What's your guess? Who thinks yes? Who thinks no? I'm such a teacher. Well, the ones who said no are correct. And if you know a little bit about psychology, then you would have already estimated that by the way I asked the question. But this ain't gonna work. Why not? Think about it some more. I'll demonstrate. So now it will obviously not execute the transaction because the simulation already fails. And we'll once again get the instruction error in instruction 0. Already in use, we see it back here over my shoulder. But if I had a different name, my second name, then it should work, right? That should work now, right? Right? We simulate it and then we execute it and it should work, right? I'll show you how it works. I'm having fun with this. Probably way too much. So, Do you see that? This is fun. Actually, I have never seen this before, but it's really nice. It's really nice because it should teach us something. What is that? The signature. What does all ones mean in base 58? Well, all zeros in binary. So the signature is all zeros because we didn't sign. But the simulation gave us success. The simulation was like, yes, this is gonna work, provided that the right signatures are defined. Our simulation succeeded, but the actual transaction, I mean, I could, paste that into Explorer, but it will tell me that this is not a valid signature. Piss off. Yeah, page not found. I mean, it's kind of weird. I would not have expected that, actually, to be honest. But yes, I am skipping pre-flight, and I'm trying to submit a transaction that is not even signed. So, I mean, the good news is I don't have to pay the transaction fee, but the bad news is there is also no transaction because it's just an invalid transaction because the signers are not there. So it's weird that I get this as a signature, but that's what happens if you skip pre-flight. So let's not do that for a second, and then we'll see what's going wrong here. So all the students who said, no, it's not gonna work, it's because we didn't sign it. You guys are correct. You're my A+ students. Here, have a star. What am I, a primary school teacher? There we go. Now same thing, the simulation went through, but then the second simulation, nope, that's not even a simulation. Here we just get the transaction signature verification failure. I'm not 100% sure who does that, if that is just me locally or if I actually bother the RPC to do it. But I think it's already me locally where I check is the signature valid before I send it, and it's not. So I already fail here in the send raw transaction. I think I don't even annoy the RPC with it because my signatures are not valid. Anyway, so we didn't even simulate because we're missing signatures. So what do we need to do? Well, obviously, it would be good to, sign the version transaction. I just sign it with my key pair, and then that should work. Or wait, students, question, does it work? Who thinks yes? Who thinks no? Well, I think yes, but then I'm never sure, so I'll try it out. But I'm pretty sure that it's gonna work now. Otherwise I get a minus and the sad face. Okay, it is working. I'm just always, when I see program logs, I'm like, the transaction simulation failed. But no, because usually they're only displayed if it fails, but I now print them manually, so yeah. And then I get the signature. That does not actually mean that it succeeded, but since we were not skipping pre-flight, it's fairly safe that it succeeded, because in the simulation it succeeded. So not just in our simulation without the signer, but also here when the RPC simulated it, it succeeded. And so the only way how it would not be successful is if the state of the cluster would already be different from the state of the RPC, then it could happen that it still fails. But that's highly unlikely. And in our case, it's not the case. In our case, that's not the case. We get success. Our transaction goes through. We pay for the account and the transaction fee, of course. And we've created another account. Cool. So that concludes our conversation about simulations. We'll come back to using simulations, but I think now we have a basic understanding of what they are and why they're useful. And we can move on. Where do we move on to? Let's move on to return values. Why not? Let's try, because I've actually never tried working with return values. Let's see if we can get my program to return something. I'm actually having fun with this today. So let's change our program a bit. I'm gonna make a get remaining. I'm lazy. Get remaining just takes data account that we don't initialize new anymore, but we do it like that. I could store the bump as well in the account, but can't be bothered to do that right now. So we still need to provide the name because we need that for the PDA. Oh, but then I also need to provide the user. Okay, might as well. Might as well provide the user. And yes, it could be a signer. It really doesn't matter because the way we're going to use it, we just use the message and not the actual transaction. But I'm spoiling here, so let's just keep it as a signer. So the only difference is I don't initialize this account. I just use it. All I'm gonna do, I also skip the require, because if the name is too long, then it's not gonna just find the right PDA anyway, and then that's all. So all I'm gonna do is I'm gonna read my remaining, and then I've never tried this, but what would happen if I put it in here? Does the OK always have to be of empty type, or could I return something here? The result, can the result be not of empty, but of U32? Because if I provide a result U32, my hair, yeah, look, my hair is pointing there. Then I can put the U32 in here. That would be a return value, right? So this is how this instruction would now return something. Let's see if that actually works. Because as I said, never done that. Question 1, does it build? Yes, it does. Damn it, I will not have enough soul to update this program. Damn, I don't have enough soul. I need another 1.7 soul. Come on. Yes! Wow, if you're that happy about the definite airdrop, then something is really going wrong there. But hey, now I should be able to deploy. Yes! I'm having way too much fun today. And I love it. Deploy success. So we're gonna call the get remaining, which just needs the name, no data, and the account, the user, because the data account is derived with seed inference, and the rest stays the same. And I just simulate this now. So I just simulate the get remaining and see what comes back there. I'm already so interested if I get a return. Interesting. Look at that. So we get success and we get this as return data, which is base 64 encoded. Obviously, because I mean, the communication between the RPC and my client is still HTTP, so text-based. So they will encode all the data in some text encoding, like base 64 makes sense because it doesn't really need to be human readable, and we want it to be more efficient than base 58, which mainly use base 58 such that our addresses are less likely to be confused with each other. So API, for instance, that I don't confuse the I, if it was a capital I, that I don't confuse it with a 1, something like that. So the base 58 was introduced to remove a few characters that are just likely to be confused. Base 64 doesn't do that. It uses a bunch more characters because we don't care about, and therefore the strings are a little bit shorter, which if you transmit a lot of data makes a difference. So base 64 encoding makes sense in this case. Wow, I'm talking a lot today. And this is the data that is returned. I could already assume that the equals here is the 0. In fact, I want to test this. What if I were to return 0, I would expect that to be, so can you please anchor, build, and deploy? I mean, this is actually super quick now, also on DevNet. It's pretty cool. I remember times when I deployed to DevNet and I was really waiting a long time. Let's see. And I just like to play around with this, right? That's how you learn. You try out stuff and then you see, that happens if I do that. Cool. Oh, wow. Now it gives me return data 0. Wow, that is strange. I would not have expected that. But maybe it interprets the 0 as a not present. Okay, let's return 1 then. But yeah, I assume the RQ, that's the 69. And let's use an online converter. Decode. Oh, gives me a capital E. Okay, so it encodes it into a string. But that makes sense because I think capital A is 65. So A, B, C, D, E That's plus 4. 65 plus 4 is 69. So yes, the capital E is 69. It's just as an ASCII character and not as a U32 as I had it. But yeah, so that means the RQ is the 69. This one, there we go. Now with this converter, I could also write some source code that does me that. But like, there we have it, the 69. And just equals, I assume, is zeros. No? What? 1 equal is the 0. Okay, yeah, that makes sense. 2 equals is not 0 anymore. This is weird. This is weird, but I don't need to understand it. It's just base 64 encoding. Let's see what the 1 is. That's probably some character equals equals equals, because 1 byte is set to 1 and then, no, it's AQ equals. Maybe it's always 2 characters that make up one number. Does that make any sense? I could read up on base 64 encoding, but it's not so important. I mean, I'm digging rabbit holes again once more. Essentially, what we get here is base 64 encoded, and maybe the RPC can select something different here, but base 64 makes sense. And if we decode that, then we get our number, the return value. That's basically where I wanted to get to. So AQ will be 1. Don't ask me why AQ is 1, but the proof here, it is. Now I kind of want to learn about base 64, but it's really not that important. It's just, okay, moving on. We need to make progress here, man. I'm going to keep returning my return value. And now I can do fun stuff like from my simulation, from the value, from the return data, maybe do something like if there is return data, then we get the return data, and that has a data and a program ID. So we saw from which program, program ID was my program that returned it. And we know that it's this, so I can ignore it. But then the data, this one, is apparently a list. What's the type? Yeah, it's string. Okay, the type, check this out. The type actually only allows the string and base 64. So the second part of this array always needs to be base 64 anyway. So we can basically already be sure that the first element here, this is the base 64 encoded string of the data. So this is now the base 64 encoded string. So now we just need to buffer from encoded data with base 64. I could also, instead of putting base 64 here, could be like the data 1, but actually I kind of almost find it cleaner or nicer if I, have base 64. Anyway, so I decode that into this buffer now, and then I can, how do I get it out? Because I know what to expect. I just read in 32. And then I'll just log it. Cool, let's see. Attempt to access memory outside of buffer bounds. So apparently we just get, yeah, but that would make more sense that 2 letters are 8 bytes. Base 64. Base 64 means there are 64 characters. Like base 10 that has 10 different characters. Base 64 has 64 different characters. Hex has 16 different characters. And in hex, 1 character, we're gonna learn something about encoding here, Stu. In hex, 2 characters make up 1 byte. Why? Wow, my head is starting to explode. I mean, this is so simple and I can't explain it right now. 1 byte is 256. 16s times 16 is also 256. Okay, so it doesn't have an overlap with actual bytes anymore. And that's why also the first 2 characters are responsible for the first byte. And that's why we get this AQ here. Because 64 alone is not enough to represent the first byte, but then I need 2 more bits to represent a byte. When do I get another overlap with 64 and 256? Yes, this is a rabbit hole that I'm digging into that you can skip if you want, but I'm teaching you some computer science stuff now. Wait, can I make this? This has base 16, this is base 64, and this is base 256. If I put byte after each other. And then let's go with the exponents. So if I have 1 hex digit, How do you do power? Yeah, there we go. Base and exponent. Okay, so we do that. So if I have one hex digit, then I can have 16 combinations. If I have two hex digits, then I can have 256 combinations. Now, 256 is conveniently the same number as this. So with two hex digits, I can represent 1 byte. That's the easy thing. Now, if we do the same thing with base 64, then this whole thing is gonna get more complicated because, you know, there is no thing between with the exact 256. So I can't represent 1 byte exactly with a number of base 64 characters. But my question now is, how many do I need to have an overlap again? So how many base 64 characters represent X bytes? And for that you could do the smallest multiple, the smallest common multiple, or the greatest common divisor, something like that. I didn't pay attention in math class, so I'm just gonna build myself a spreadsheet and hope that I can manually see it. That's my strategy. Just gonna go with those numbers and then see if any of those numbers are in here. This one is not in there. This one is also not in there. So 2 bytes are also not represented with a fixed length of base 64. This one, aha. This one is. This one is this one. So 4 base 64 characters, gonna highlight this, represent 3 base 256 characters, which are bytes. So we now know that this thing here represents 3 bytes because it's 4 characters representing 3 bytes. Okay, which means if I read 4 bytes for a U32, then I get an error like this one, buffer out of bounds, because apparently I don't get more zeros here. I don't get more zeros. If there is 0, then it doesn't show anymore. How can I now, from those 3 bytes that I get here, how can I still get the value properly? Because it could still be a 32 little endian. In fact, let's have a look at that. Let's look at what that would look like if this wasn't just a, 1 byte number, but that was actually more than 3 bytes long. Let's do, so, capital max. If I return a larger number, what will happen then? I actually really like how fast it is on DevNet to deploy. Check this out. I mean, it takes me longer to compile my program than to deploy it. Look, it's pumped out and it's ready. Wow. So let's see what I get now. Here we go, more bytes. 1, 2, 3, 1, 2, 3. Maybe the equals means it's the end. Could that be? I don't know enough about base 64 encode. But yeah, I mean, that looks like this is the data. And my return value is minus 70, which makes sense because we had the max value minus 69, and in negative we have one more number. So it's minus 70. That's what the 2's complement does. Because I was reading an int 32 instead of an unsigned int. If I were to read an unsigned int, then I get the big number, which is, the max value of U32 minus the 69. So that's 2 to the power of 32 minus 69. That should be this. So yeah, then it works. But coming back to how do I get it to work if I don't know how much I'm returning? Just returning my remaining. Probably the buffer knows how long it is. I would like to give it a minimum length. So instead of just buffer from this, I say allocate me 4 bytes and write this. Write returns me a number though, telling me how much it's written probably. Allocate the buffer, then I write to it, and then I read from it. And this should now also work with a smaller data size. So if I just get the first 3. If it just writes me the first byte or the first 2 or whatever, I can still read 3 because the remaining 4s are just zeros then. That's what the alloc allows for. Yeah, so now it works. Cool. Now I can have my 69 read from the return value of a transaction simulation. Now, you, as a good student, would be like, but Andy, why the hell would you do that and make the program, the poor program, have a function that returns something if I could just query the data account directly and read the remaining field? Because that's a fairly trivial thing to do. You literally just need to go program.account.dataaccount.fetch and then the address. Okay, fair, I need to derive the address now because it can't infer that from use and whatnot. But okay, then I'm gonna do that real quick, and then I fetch this, and then I can literally say account.remaining. That should also give me the 69. There you go. You're a good student. You figured that out. I can just, read the data from the state. But, says Andy, the cool thing about the transaction simulations and the return data is that you can actually use compute. So it's not just a static reading the state. I mean, this could be kind of an API, right? So reading account data is kind of an API if the API only supports reading values that are in the Solana state. That's an API that is already supported. You query with Anchor abstracts it away here, but this is essentially a get account info, so an RPC request with get account info, and parse the data, and bam, you have it. That could be an API. But if we work with such simulations, then we can actually use compute to compute values, like we already did when we were calculating this higher value with the max minus remaining. If I want this value, I can make myself a function in the program and return whatever I want to return. And this value is nowhere in the state to be found, but I can return it. And then I can read it here from the return data of the simulation. And because we're just simulating it means that we don't actually execute anything on the Solana cluster. So we also don't need to pay transaction fees to do that. Yes, it is code in the program, and yes, therefore we need to pay a little more in rent for our program, but this could be a function that is never actually called inside our program, right? This could be something like, like those read-only functions that Solidity supports, right? Just read and then you don't need to pay gas fees to just call the read functions. We can do something like that in Solana as well. I mean, kinda, by just not really calling this, not ever CPIing on this, or not ever calling this instruction. Only simulating transactions that use this instruction. And if at that point you, my good student, are like, what the hell is he talking about? What is that good for? Can't I just do this calculation outside here in my front end and still query the data like this? Then I'm like, yes, you're a good student, yes. You could totally do that. But that requires you as the front-end dev to know what you're supposed to do. And yes, of course, you can always figure that out by reading the source code of the program and then doing the same thing in the front end. But you could also just simulate the transaction and have the program give it to you. That way, only the program needs to have the implementation, and the front end just queries that. We just use this as an API, which is called the interface. The interface in this case being our get remaining instruction that we misuse as just an interface to essentially have our RPC provider be our API. So we're totally exploiting the RPC to do calculations for us just because we don't want to implement it. But that's a cool concept. Why is that a cool concept? I have 5 more minutes until I have a meeting about the Berlin Hacker House. There is a SIMD or a Solana request for comments, a sRFC about interfaces. I don't know if it was this one. I think it was an older one. And I don't want to go too much into depth here, but the idea that they had is, since every program might need different kinds of accounts for doing a transfer, we can do something like what I did here, create a function that returns which accounts are required for a transfer. And then for the actual transfer, you provide those accounts. So you do a transaction simulation that returns you a list of accounts, and this list of accounts you provide to the actual program call, whatever your actual program call may be. This could be used for an interface for transfers, for instance. Interface basically meaning I always have the same inputs, and in this case my inputs would be something like source token account, destination token account, mint, and authority. This could be, our interface could take those into account and then calculate which other accounts I need to actually call the program. So for instance, this could derive our associated token accounts or our metadata account if it was an NFT or whatever. It's an interesting proposal. Not sure if this will be implemented. I don't think so, because there are other RFCs for interfaces, another one by Toli that is more technically complex, so I don't want to go into that. I don't even want to go into this here too much, just as a high level overview. Correction, it was not the sRFC 03, it's the number 10 program trade transfer spec that is talking about that. Got that confused, I didn't actually read them. That allows target programs to require additional accounts. And the way we get those additional accounts is with such a simulation. So there's a pre-flight transfer instruction that has a specific discriminator. The accounts we put in are the owner, the receiver, the authority, and the mint. And all the rest will be inferred by the program. And then the actual transfer, that will then have the list of those pre-flight transfer accounts added to this instruction. And there's this off-chain usage, so we just simulate, we're not really on-chain. Essentially, we simulate the pre-flight transfer, so what we did here with our get remaining, just that we don't return a U32 but a list of account matters, and the simulation will get me the list of those account matters, and then we can append those in the remaining accounts. So that is how we could use this whole simulation and return values for an interface or a trade, a program trade for transfer. Yeah, so here he gets the return data, A64 decoded in data. The first 4 bytes are how many account matters there are. And then essentially we decode all of them and we have the remaining account matters. Nice. Pretty much what we did. It's just a simulation. And then we can append those remaining accounts in the other transaction like this. That's using what we learned today. So if you want to understand sRFC 00010, then this was a good video to watch. Of course, there are limitations with this, and we don't know if that is actually ever really used. But it's good to understand those sRFCs, so that's why I made this video today. And I think I want to end the video here. I think it's a good time to end. Yeah. As always, students, I hope you learned something today about transaction simulations, about return values. First time I ever did something with return values. It's that simple. It's just literally boom. Put it in the OK and say what you need in the result, right? And we could, of course, do more than just U32s. Here we can do more complex stuff like a list of pub keys. That could then be used for an interface implementation, which is why I wanted to learn a little bit about it, about those return values, and get you up to speed on what transaction simulations are and all that sweet stuff that a Solana dev definitely needs to know about. Yeah, and with that, I want to finish this video. Me and my nice hair are gonna go have breakfast now. You can go check out the other videos and like and subscribe and all that sweet stuff, dear students. And yeah, keep learning about Solana development. Interfaces are gonna be an interesting topic. I'm gonna make videos as soon as I have the idea of which one is actually gonna get implemented and used. because there will be interfaces, I'm pretty sure. We just don't know which standard yet. So I will not want to confuse you with too many standards. I just teach you about some basics that you will need to understand those interfaces. Once they're actually properly released and supported, then we're going to talk about them in more detail. So until then, bye bye.